Alright guys, this is the second part of the video, so if you didn't watch the first one, please go watch the first one and then come back to this one. We are looking at the next example. Please copy. We have -5 over x squared plus x equals x plus 6 over x plus 1. In this example, we have binomials in the denominator, so you actually need to factor first. So let's go ahead and do that. I have -5 over, in my first denominator, I can see x squared plus x, they have a GCF of x. So I'm going to factor out my x, and then I end up with x plus 1 equals x plus 6 over, I really can't do anything to my denominator. I have an x plus 1. There's no GCF or anything, so it just stays as x plus 1. So for my step 1 is to find the LCD. And remember, you're looking for what they have shared. So x plus 1 is shared, and then they have an x left over. So the LCD would be x, because that's what's left over, and x plus 1, because that's what they have shared. And then I'll go ahead and do it now. I want to look for the excluded values. Excluded values are, when would this be a 0? So if I had x equals 0, that would be 0. Then I also have x plus 1. If I make that equal to 0, I would end up with -1. So my excluded values are 0 and -1. We cannot have a 0 or -1 for our answer. Step 2 is then to multiply by the LCD to every single term. So I need to take my fraction. You want to do this one, the one that's already in factored form. So I'm going to do -5 over x times x plus 1 times my LCD, which is x times x plus 1 all over 1, equals x plus 6 over x plus 1 times the LCD, which is x times x plus 1 over 1. And then step 3 is to clear out the denominators. So that's still part of step 2. So I can see that x cancels out with the x. My x plus 1 cancels out with the x plus 1. So here I have 1 left over and a 1 left over here. X plus 1 cancels out with x plus 1, so I'm left with x and x plus 6. And I forgot to circle my -5. So when you do step 2, when you multiply by the LCD, all of your denominators should go away. That's the whole point of multiplying by the LCD. And then you look at what you have left over and you multiply those pieces. So I have a -5 times 1, which is just -5, equals, then I have an x times x plus 6. So I'm going to put the x first and then the x plus 6. Step 3 is to solve the remaining equation. So here I have -5 on the side. I can't really do anything. And then here you want to distribute. So x times x is my x squared. And then x times 6 would give me 6x. And then notice, I need to solve for this. I have a quadratic. So anytime you have a quadratic, you need to factor. So in order to factor, I need to move the 5 over to this side. So I need to add 5 to each side. And then my remaining equation should be x squared plus 6x plus 5 equals 0. And in order to solve for x, we're going to have to factor. So in this example, a times c would be 5, and my b is 6. So two numbers I'll multiply to 5 and add up to 6. That would give me a +5 and a +1. So this would end up being x plus 5, x plus 1 equals 0. And then you need to solve for x for each piece. Make each piece equal 0. X plus 5 equals 0. X plus 1 equals 0. and then subtract 5 to each side, my x would equal -5. And then over here I would subtract 1, so my x would equal -1. Then I want to go back and check my extraneous solutions. Notice I have x equals 0 and -1. This time I have a -1 and I had a -1 in my solution. So therefore this is not a solution because it's excluded value. So this is an extraneous solution because it's an excluded value. You are not allowed to have a -1 as an answer, because if you have -1, then your denominator would be 0 and you can't divide by 0. Then you want to check x equals -5. Neither of these are -5, so this is a valid solution. So x equals -5 is your final solution set. I do want to go over this example with a trinomial as well, so please copy this one. We have 56 over x squared minus 2x minus 15 is equal to 7 over x minus 5. So if you remember, the first thing you want to do is to factor out your denominator. So this would be 56 over, in this first denominator, it's a trinomial, so I need to factor. 8 times c is -15, and my b is a -2. So two numbers that multiply to -15 and add up to -2. I can think about 3 and 5. But one of them needs to be negative because that's negative, and I need a -2. So therefore the biggest number needs to be negative. So then your trinomial will become x plus 3, x minus 5. And then my second fraction, I have 7 over x minus 5. I can't really do anything to that. Then you want to check for the LCD. So that's step 1. I'm going to start over here because then I run out of room. So LCD, what do they have in common? I have a x minus 5 in common and a x plus 3 left over. So x plus 3 and x minus 5. Remember, what they have in common, you only write it one time. And then you want to check for excluded values. My excluded values, when would this be 0? So if I make this equal to 0, subtract 3, I would get a -3. So -3 would be excluded value. And then x minus 5 equals 0. Add 5 to each side. So 5 would also be an excluded value. My step 2 is to multiply. So if we were to multiply for step 2, remember, you want to stick to this one that's already factored. So we're going to have 56 over x plus 3 times x minus 5. And you want to multiply by the LCD, which is this, x plus 3 times x minus 5. X plus 3 times x minus 5 all over 1 equals 7 over x minus 5 times the LCD, which is x plus 3, x minus 5 again, all over 1. And then you want to clear the denominators to see what cancels out. So x plus 3 cancels with x plus 3. X minus 5 cancels with x minus 5. So over here I have a 1 left over, and these canceled, so you have a 1 left over. Then x minus 5 cancel. So I have 1 left over here, and then I have a x plus 3 left over here. I have my 56 and the 7 left over. So you want to multiply all your leftovers. So I have 56 times 1 is 56 is equal to 7 times x plus 3. And then step 3 is to solve the remaining equation. So I can't do anything here, so then multiply 7 times x plus 7 times 3. So 56 equals 7x plus 21. This time I don't have a quadratic, this is linear. So linear, you just solve. So subtract 21 on each side. So this ends up being 35 equals 7x. Then you need to solve for x by dividing by 7. And then you end up with x is equal to 35 divided by 7 is 5. And remember, you need to go back and check your excluded values. Notice x equals 5. We're not allowed to have a 5. It's an excluded value, so therefore this is an extraneous solution. Extraneous. Therefore x is not equal to 5. Oh, look at that. I don't have any other options. My solution is extraneous. So my final solution set, you are actually going to say there is no solution for this example. Or the symbol for that is like a 0 with like a cross through it. That's called the null symbol. So there's actually no solution for this example because our answer was an extraneous solution. And I think the rest of the examples are practice problems. So I'm going to skip these. Closure. What is an extraneous solution, and explain why is it necessary to check for extraneous solutions when solving a rational equation. Well, as you notice in the last two examples, our extraneous solutions are a solution that is an excluded value. That is not part of the domain of the expression in the equation because you can't divide by 0. It is necessary to check for extraneous solutions while solving a rational equation because some solutions can create a 0 in one or more denominators, making the expression undefined. So it's very important for you guys to check for extraneous solutions at the end, okay? Alright guys, you guys can get started on your exercises 4B-2. Those will be due on Tuesday when we come back. There is no school on Monday. Please be focused the rest of the period working on your homework. Alright, have a good day.